So this is question number 81 from June 2020 mathematical science paper. So we have our open disk D, which is defined in a complex plane. Mod Z is less than 1 with the open unit disk, and let f is d to d be a holomorphic function. Suppose that f0 equal to 0 and f dash 0 prime 0 equal to 0. So which of the following are the possible values of f half? So we will solve this problem with a theorem. So what is the theorem? First let's state the theorem. So the theorem states that z equal to z0 is 0 of order m of fz. So z equal to z0 is 0 of order fz if f of z0 equal to f prime z0 up to f of m minus 1 z0 is equal to 0 and f m z0 is not equal to 0. Okay, so if we have the in holomorphic function we have a lemma, that is the Schwarz lemma. Okay, so an extension of the Schwarz lemma states that if fz be a function such that point 1 fz is analytic in mod z less than 1 and fz mod of fz should always be less than 1 for all mod z less than 1, and point number 3 is fz has 0 of order m at z equal to 0. Okay, so from here we can say that f of fz mod of fz will always be less than equal to the z to the power mod of z to the power m for all mod z less than 1, and we have considered the mod fm at 0 is always be less than equal to m. So from here in our case we can that fz has a 0 of order where m is greater than equal to 2, that m at equal to m greater than equal to 2, it must be at least m equal to greater than equal to 2 for f0 has a 0 of order. Okay, of this order either greater than equal to 2. So to find the value of f half, what we can do is put mod of f half, which will be less than the mod half square. It is nothing but 1 by 4, so which can be written as the range is minus 1 by 4, which is less than equal to f of half since it is under mod, and the range is less than equal to 1 by 4. So in our case we have to find the possible values of f half. So possible values of f half is 1 by 4 and minus 1 by 4. Question number 82 is let n be a positive in integer. For a real number r greater than 1, let z of theta be r e to the power 1 by theta, and where the theta is ranging from 0 to 2 pi. So the set, so what is given, the set, suppose the set is S, is given as theta, which belongs to this semi-closed interval of 0 to pi, and here it is given that mod of z theta to the power n plus 1 mod of z theta to the power n minus of 1. So let us consider that theta belongs to is an element of S. So we can write, just simplify this. We have to simplify this theta of n plus 1 equal to z theta to the power n minus 1. Now if we put the value of z theta on both sides, so what we will get, this will be r of e to the power I theta to the power n plus 1, and similarly with the mod will be r e to the power I theta to the power n minus 1. Okay, so here if we square both sides, plus 1 to the power whole square, and also this do this side r e to the power I theta n minus 1 whole square, right? So we can simplify it over, so it will be nothing but r to the power n eta I n theta plus 1 within mod whole square, and this is simply r to the power n minus 1 whole square, right? Now simplify this, it is within mod, so we can write it over here in this manner. So this can be written as r to the power n e and e to the power I n theta plus 1, and r to the power n e I n theta plus 1, which is a complement, right? We can write it in the same manner, and just r to the power 2n minus 2 r to the power n plus 1, right? So now simplify the LHS, so we will get r to the power 2n, which will cancel out, plus rn e to the power I n theta plus rn e to the power minus I n theta plus 1, and here it is side r to the power 2n minus rn plus 1. So here it will, these two will both cancel out. So we will have, so if we took let's change the thing. So if we took rn common from here, so rn e to the power I n theta plus e to the power minus I n theta equal to minus of 2 to the power rn. So here we have it is rn, so it is r to the power n. Similarly here it is r to the power n. Okay, so this rn will cancel out, and so we will left with this. So we can do one thing over here, that if we multiply both sides, both the numerator and denominator by 2, so we will have this e to the power I n theta plus e to the power minus of I n theta by 2 equal to minus 2. So this term we can write it e to the power I n theta plus e to the power minus I n theta by 2 equal to this 2 of cos n theta equal to minus 2, nothing but the result is cos n theta equal to minus 1. Okay, so let's check with the option. So our option in this case is for theta in the closed open interval, semi-closed interval 0 to 2 pi. So option 3 is the correct answer. Cos n theta equal to -1.